Hi, how's it going? Welcome to Code with Z. In today's video, we gotta go from this position here all the way to this position here. Why? Well, that's because this is what LeetCode 64 minimum path sum is asking us to do. As you can see, it says we're given an m by n grid like this, and it's filled with non-negative numbers. Well, non-negative numbers indeed. And it says we need to find the path from the top left to bottom right. So basically, from here to here. But we have to find the minimum path to go from top left all the way to bottom right. Now, what do I mean by this? Well, if we check, each cell has a number inside of it, and that number basically tells us how much we should add to the sum of our path. For example, if we start from this position, we're gonna add 1 to the sum of our path. So the sum is gonna be 1 because it's gonna be the first position. Then, for example, if we go to 3, we're gonna say, all right, we already have 1 inside of our sum, and now we have 3. 3 plus 1, that's gonna give us 4. So now our sum is 4. And then, for example, if we get to this one here, we're gonna add this number to our sum. We already had 4. Now when we add 1 to it, that's gonna give us 5. So we basically have to go from this position all the way to this position, but with the minimum path, as you can see. And here it says you can only move either down or right. That means if we are here, we can't go to left or up. The only moves that we can make is to right and down, and we're starting from this position here. Alrighty, let's solve this together. I'm gonna put this here, and now I'll explain to you how we're gonna solve this and why we're taking this approach. So we wanna know how much it costs to go from here to this position here, right? And we can only go to right or down. So why not just calculate the cost that's required to reach each cell? For example, if we go from here to 3, we already had 1. And if we add 3 to it, that's gonna be 4. So the cost to reach this cell is gonna be 4. So if we actually calculate the costs for all of these cells, at the end we can just return the cost that we found for this one. So let's define another grid that's basically empty, and we're gonna calculate the cost that's required to reach each cell. So for example, if we start from this position here, we're gonna have 1. Why? Well, because we have the number 1 here, and this is our starting point. Currently, our sum is 0, and we only add 1 to it. And we know we can only go to right or down. So first, let's calculate the costs that's required to reach this cell and this cell. We've already calculated this a bunch of times. We know it's 4. Why? Well, we said our sum is 1, as you can see, because that was the first position. Our sum was 1. Then we said, all right, we want to get to this number, and our sum is already 1. So 3 plus 1, that's going to give us 4. And now if we want to get to this position, our sum is 4 and the value of that cell itself is 1. So that's going to give us 5. Now that we have the first row, as you can see, we calculated the first row. Why not calculate the first column as well? And then we can see what we can do with these ones that are kind of in the center, because the first row and the first column are simpler. Why? Well, because there's only one way to get to them. For example, if we start from this position and we go down, there's no possible way that we can go back here because we can't go up. For example, if we go to right from the first position, there's no possible way that we can get to the first column because there's no left. So because it's so simple to calculate these, we're gonna start with them. So let's calculate the first column as well. As you can see, if we go from this position to this position here, our sum is 1 and the value of this position is 1. So that's gonna give us 2, like so. Now, if we wanna go from this position to this position here, our sum is 2 and the value of this position itself is 4. So that's gonna give us 6, like so. Now that we have the first row and the first column, let's see what we can do about these. You see, if we wanted to reach this position inside of the grid, we can get to this position in 2 ways. We can either come here and then come down, or we can actually come here and go right. So there's 2 paths that are leading to the cell that we want to explore. So let's see what's the minimum path. We're going to be like, all right, we want to get to this position, right? And we can get to this position from 2 different positions. And each 2 different positions have a different sum. If we come from this position to this position here, we need to add 4 to 5 because that's the sum that we have in this position. But if we actually go from this position to this position here, we need to add 2 to 5 because that's the sum that we have in this cell. And as you know, we're looking for the minimum path. So we're going to pick the minimum number, and that's going to be 2. And that's going to give us 7. 5 plus 2 is 7. Now, if we want to get to this position here, we're going to be like, all right, we can either go from this position to 1 or from this position to 1. And we have the sum of both of the positions that we have here. So we're going to be like, all right, we want to reach 1, but let's see what the minimum path. We can either add 7 to 1 or 5 to 1. And as we all know, we're looking for the minimum path, so we're going to pick 5, and we're going to say 5 plus 1, that's going to give us 6. So now we have the cost required to reach this position here as well. As you can see, we're slowly finding all of the answers, and this is our goal. And then we're going to be like, all right, let's see how much it costs to get to this position here. Well, if we want to get to this position, we can either go from here to here or from here to here. So we're looking at the sum of these two positions that are 6 and 7. The minimum one is 6, so we're going to say 6 plus 2, that's going to give us 8. This is how much it costs to reach this position from this starting point that we have here. And then we're going to be like, all right, let's see how much it costs to reach this position. If we want to reach this position, we can either come down from this cell or go right from this cell. So we're looking at these two sums. Our current value is 1, and if we want to reach this position and then come down, we already know how much it costs to reach this position here. It costs 6. And for this one, it costs 8. Now we want to reach this cell that we have here. So we're going to be like, all right, we're going to add this to the cost that we already have, but we want to find the minimum path. And between 8 and 6, 6 is minimum. So we're going to say 1 plus 6, and that's going to give us 7, like so. And this is going to be our answer. And that's basically it. It costs 7. So we're going to basically return the value that we have inside of the last cell in the grid that we just created. So we were given a grid and we used it to define another grid that each cell has the value of how much it costs to reach that cell. So we're going to first define the grid, and then we're going to find the values in the first row and the first column. And then we're going to find the values that we have here by finding the minimum between these two numbers. For example, if we're looking for the value of this cell. So if we were exploring how much it costs to reach this position here, we need to find the minimum value between the cell in the same row but the previous column, meaning this number that we have here, or the cell in the previous row and the same column, meaning this cell that we have here. And we saw when we calculated the value of this one, we added its own value and the minimum between these two. The minimum was 5, so 5 plus 1, that gave us 6. Now, let's code this in the simplest way possible. Alrighty, so as you can see, our grid is M by N. The letter M represents the number of rows that we have, and the letter N represents the number of columns that we have. So let's just define those. We're going to say const M is going to be grid.length, and this is going to be representing the length of our rows, and we're going to say const N. This is going to be grid at the index of 0.length, and this is going to give us the basically number of columns that we have. Then we need to define our own grid. As you can see, we're given this grid that's basically this picture that we have here, but we have to make the grid that we saw, the green grid that we have in the slides. So I'm just going to name it DP, like so, because this is going to be a dynamic programming approach, and we're going to say array at the length of M. All you need to know is that I'm basically making the grid that we saw, with the only difference that in the beginning our grid was empty, but here we're going to fill it with zeros in the beginning, and then we're going to update the numbers. The map, and then we want to keep on looping, and with a length of N, and we want to fill it with zeros as well. This is going to basically make our grid. But if you want to know how it actually works, it basically makes an array with the length of M, and it's going to fill it with zeros, and then it's going to loop through that array. And for each element inside of that array, it's going to insert another array with a length of N, and then it's going to fill it with zeros. We have our green grid and our original grid that was given to us. And the first thing that we did was to fill the first row and the first column. And if you remember, we said the first position is going to be equal to this value that we have here. Why? Because it's our first position and our sum is 0, and we only add the value, the cost that we have in this cell to our sum. So we're going to say DP, basically the green grid that we made at the first row and first column. So basically this position that we have here in the picture should be equal to grid at the first row and the first column. This basically adds this number 1 that we have to our grid. Then we're going to fill the first row and the first column. We're going to say 4, because we want to loop through it basically. For let column being equal to 1, you're going to see how this works. Just one moment. And we want to keep on looping as long as column is smaller than N, and we want to increment column on each round. Here we're going to say DP in the first row and dynamic column. Basically, in the green grid that we had, we're gonna loop through the first row and we're gonna say the value for each cell should be actually equal to grid at the index of 0 and column plus the previous sum that we had. We saw this in the slides, right? We said we're gonna add the current value of that cell and whatever we had in the sum. So we're gonna say dp, because the sum lies in the dp grid. So 0 and column -1. And this is gonna basically give us the value that we have in the previous cell. And then we're gonna have the same thing for the first column. This took care of the first row, as you can see, dp at the index of 0. So we're actually looping through the cells that we have in our green grid in the first row. Now we're going to take care of the first column. We're going to say for let row being equal to 1. And we want to keep on looping as long as row is smaller than m. And then row plus plus. I forgot a plus sign here. And then inside of this loop, we have to update all of the cells in the first column. So we're going to say dp with a dynamic row, but the first column should be equal to, and this basically loops through each cell that we have in the first column, and we're going to have something similar. We're going to say it should be equal to its own value. So grid, row, and the first column, plus the cost of the cell above it, just like we saw in the slides. So that's going to be dp row -1, but same column. So basically the cell above it. And then we have to take care of these cells that we have in the center. For example, if we wanted to calculate the cost to reach this cell that we have here, we said we're going to add the value of the cell itself plus the minimum path between the cell above it and the cell left to it. So let's say that first of all, we're going to have a loop for let row again equaling to 1, and we want to keep on looping as long as row is smaller than m, and we want to increment row on each round, and then for let column being equal to 1, and we want to keep on looping as long as column is smaller than n, and we want to increment column on each round. Here, because we need to loop through all of the cells here, we're going to have a nested loop, and we're going to say the value of this should be this plus the minimum between these two. So we're going to say dp of row and column should be equal to first the value of itself, so row and column, plus the minimum, so math.min between these two cells. Well, if we check, the cell above it is gonna be previous row, same column, and the position of the cell left to it is gonna be same row, previous column. So we're gonna say the minimum between dp, previous row, but same column. Let me drag this to the left like so, or dp, same row, but previous column, like so. And after this is done, we're just going to return the value in the last cell. So we're going to say return dp, the last row and the last column. And that's going to basically give us the answer just like we saw on the slides. Now let's run it. I hope I've not made any typos. Let's see. And yep, we got accepted. Let me submit it and see if we're going to actually pass all of the test cases. Moment of truth. Let's see. Yep. That's awesome. Thanks for watching. Don't forget to like and subscribe and keep on coding.